This video is about parallel and perpendicular lines. When we have lines on a graph, what would make two lines parallel? Okay, by definition it is that the lines will never touch each other. They're running alongside each other and they'll never touch. There's got to be a reason though. We have to be able to prove this statement. Okay? Also, we need to make sure that our two lines are not overlapping. You can have two lines on a graph if they're on top of each other. Okay, so let's say, for example, I have one line that is vertical. The other line is also vertical. It falls on the same line as before. If that happens, we call these coinciding lines. C-O-I-N-C-I-D-I-N-G. Coinciding. Okay? These lines will not be considered parallel. So if they're on top of each other, they're not parallel. But if we look at the one drawn here, they're not on top of each other because this one goes through the y-intercept of 2 and this one goes through the y-intercept of 4. Okay, so we have different y-intercepts, but there's something that's the same about these two lines that's making them parallel. Parallel lines have the same slope. So when we have the equation y equals mx plus b, our m in the equation is slope. So if we were to have a multiple choice question and we're asking which are parallel, we need to go through first, make sure they're all y equals mx plus b form. They are. They're all solved for y. So what I want to do now is I want to go through and write each slope. So the slope, the m, so if we have y equals mx plus b, and m is slope, parallel means they have the same slope. My m here is 2. On b, my slope is negative 2. C, my slope is 2, and D, my slope is negative 1/2. So now which are parallel to each other? I have a 2 and a 2, so A and C are parallel to each other. So on this slide, we're choosing which are parallel. The difference is, here they're not all solved for y, so that's the first thing that we've got to do. So the first one is, so I'm just going to write down that my slope is 3. The second one is, so I'm going to write down my slope is negative 1/2. Now, on C, I need to solve this for y. So I have y minus 5 equals 3x minus 1. Let's change colors. So when I distribute the 3, I've got y minus 5 equals 3x minus 3. And then I need to add 5 to both sides. So now my solved equation is y equals 3x plus 2. So my m is 3. And then on this last one I have x plus 2y equals negative 4. I need to subtract x from both sides. So 2y equals negative x minus 4, and then divide by 2. So I have y equals negative 1/2 x minus 2. So my slope is negative 1/2. Now when I'm looking at this, A and C have the same slope. But if I look here, my y-intercept is 2 for both of these. So are these parallel? A and C? No. A and C are coinciding. They're not parallel. Now B and D, my slope is negative 1/2 for both of those, but on B my y-intercept is 4, and on D my y-intercept is 2. So actually B and D are parallel to each other. Perpendicular lines. What makes lines perpendicular? Let's take a look at this graph. It says this graph is perpendicular. Why? How do you know it's perpendicular? First of all, perpendicular means it forms a 90-degree angle. So we know that this angle forms a 90-degree angle. It's telling us that it is perpendicular. How would we prove that here? I have a horizontal line and a vertical line. My slope on the horizontal line is going to be a 0 slope, and my vertical line is going to be an undefined slope. This one's really pretty easy. If you have a vertical line and horizontal line, they're going to form a 90-degree angle. Okay, they're going to run opposite of each other. If we look at this graph, I want us to look at the slopes, not necessarily the y-intercepts, but the slopes of these graphs. We're going to form equations. So take a moment and look at that. Okay, first we're going to form the equation for the pink line. So in order to do this, let's put both of these in y equals mx plus b form. So I need my m and I need my b. I'm going to start off with my y-intercept. So my b is 1. From there I'm going to find where it runs through another point. Let's do right here. So I'm going down 1, so minus 1, always run forwards 2. So it's negative 1 over 2. So my equation is going to be y equals negative 1/2 x plus 1. For my blue line, I'm going to come up with my m and my b. My y-intercept, my b, my begin point, is 2. See where it runs through another point. It looks like it runs through 1, 4. So I'm going to be rising 2 and running 1. So 2 over 1 is 2. So my equation is y equals 2x plus 2. Alright, I'm just going to go ahead and tell you that these lines are perpendicular. We can prove that two lines are perpendicular because their slopes, let's say perpendicular because slopes are opposite reciprocals. Opposite means opposite sign, and reciprocal means flipped fraction. So when we're looking at the slopes, I have negative 1/2 and 2. So to be an opposite reciprocal, I have to have the opposite sign. So here I have a negative, here it's positive. And reciprocal means it's a flip fraction. So if I flip 1/2, I have 2. So that's my way of proving that these are perpendicular. It has nothing to do with these y-intercepts. It does not matter what the y-intercepts are. We're looking only at the slopes. So perpendicular lines have slopes that are opposite. Reciprocals. So opposite means different sign. Or opposite sign. And reciprocal means flipped fraction. We're finding the reciprocal of the number, which means you flip it. For example, the opposite, I put these in here for abbreviations, the opposite reciprocal of 4. Okay, so opposite means we're going to change the sign. Reciprocal means we're going to flip the number. So instead of 4, 1/4. The opposite reciprocal of 3/2 is going to be negative 2/3. The opposite of negative 2 is going to be a positive 1/2. So if you're looking at two equations, the slope is 4 for one equation, the other slope is negative 1/4 for the other equation, that's going to prove that the two equations are perpendicular to each other. The two lines will be perpendicular to each other. Okay, so you write the opposite reciprocal of these numbers, so hit pause, write them down on your page, and then I'm going to go over them. Alright, the opposite reciprocal of 1/5 would be negative 5. Negative 3/4 is a positive 4/3. Positive 7 would be a negative 1/7. And negative 1 would be a positive 1. Which are perpendicular? X equals 2. What does this line look like? If it's x equals 2, it does not have y, so it's not a function. So it's going to be a vertical line. X equals 1 does not have an x, which means it has a 0 slope, which means that it's horizontal line. I know these two are going to be perpendicular to each other because I know that a vertical line and a horizontal line are automatically perpendicular. Now C, my slope is negative 4. And D, I've got to work this out. So I've got y plus 2 equals, let's distribute, positive 1/4 x plus 1/4. And I need to subtract 2. So I've got y, that's a 0 pair, equals 1/4 x minus 1 3/4, or 7/4. So my slope here is 1/4. So I've got a negative 4 and positive 1/4. Are these opposite reciprocals? Yes. So C and D are also perpendicular. On this slide, A does not have a x value, so we know that the slope is going to be 0. So if the slope is 0, it's going to look like this. Y minus 6, so let's distribute this. So I've got y minus 6 equals 5x plus 20. I need to add 6 to both sides. So y equals 5x plus 26. So my slope here is 5. C, I have an x, I don't have a y, so I know this is going to be undefined. This is not a function. And D, My slope is negative 1/5. Negative. Okay, so I know that my horizontal and vertical line are going to be perpendicular. And I have a 5 and a negative 1/5. So actually B and D are also perpendicular here.